Just to introduce myself, I'm Mark Sira. I'm the chair of the Standards Committee 21 of IEEE, and our group manages the standards and working groups for the 1547 series interconnection standards and 2030 smart grid interoperability. So we've got about 19 active standards and 7 active working groups and lots of change going on. I'm pleased to have Wayne Steck also be a speaker. I've worked with Wayne for over 20 years, and he's the vice chair of Standards Committee 21 and is probably the most knowledgeable of a person that I've met in terms of testing and commissioning equipment that's going to be connected to the grid. Don't forget to check into this session to earn continuing education credits, and we do have a quiz for you. We have a lot of slides we're going to go through. Not all of them are going to be discussed, but you have access to those in the app. So hopefully it's providing a reference as well as useful knowledge as we transmit it to you. The objectives for this session are to talk about vehicle-to-grid technology, and it's an area that's been in a lot of discussion related to the interconnection standards. We'll give you the guidelines and, in some cases, the mandatory requirements for connecting to the grid that could apply to many installations. And we'll provide general guidance for designing EV charging plazas, and hopefully we'll use this as a reference moving forward. We're going to go through a little bit of background on the grid transformation, the standards we're working on related to grid interconnection and electric vehicle charging. We'll talk about some trends in the charging plazas, and then we'll go through in detail the commissioning and testing requirements that are mandatory in many parts of the country. Just a general background on the IEEE view of standards. We think it's important that they represent a consensus view of the technical requirements or guidelines depending on what the standard is. We have standards, we have recommended practices, and we have guidelines. And they typically take 4 years to develop, and there's a wide industry collection of people that achieve consensus on those requirements. It's helpful to have a common terminology, so we're talking about a distribution transformer, and we're talking about the same thing in many different standards. They lead to modularity, which is a concept that leads to repeatable design and manufacturing. And then as the system design becomes more robust through iteration, it improves designs. And one of the aspects of that that's really helpful in developing countries is it actually creates a minimum technical requirement for products, so it eliminates market spoilage in places where cheap, unreliable products can destroy the opportunity. Here's some trends and developments with the EV charging market. A pretty steady growth that looks like it's going to continue. It's dependent on government initiatives. There seems to be a focus on putting more charging plazas in rural areas. And the challenge that came up as we were researching this is there's a big concern for users on reliability of the EV charging stations. There's a concern for interoperability. Will my vehicle work on the stations I have access to? And then accessibility in urban areas and less populous areas. I captured some data that you might find interesting. A survey in 2023 asked consumers what frustrated them, and the top things were not enough charging, public stations, the inconvenience of charging, nowhere to plug in my car at home, which is interesting, and long charging times. There's been evolution in the standard for connectors. CCS the middle one, I don't know how to say, and NACS, which is the Tesla standard. So those seem to be the dominant three that are emerging for fast charging stations. Residential still dominates in terms of volume of equipment, in terms of numbers, but retail and workplace seems to be behind significantly, but it is an area of development. This chart's interesting because it shows the states that provide public charging plazas and have charging outlets. And California, New York, Florida, Texas, Massachusetts are the leaders. In California, by a large margin, seems to be the lead. An interesting sidebar that I think Wayne's going to talk about is that those are also the states that have mandatory requirements for interconnecting to the grid. So if the charging plaza has energy sources in it that may need to interact with the grid in paralleling mode, the things we're going to go through next are mandatory. I uncovered this report, which was released in late 2023, and it was based on an evaluation of over 1 million charging stations worldwide over 10 years, and the results were kind of shocking that charging stations in the US have a reliability score by consumers of 78%. And that means, analogy would be if you pulled up to a gas station and it would be available 78% of the time, that might be a problem. So big concern, that's consumer sentiment, so, and it drives some of the market behavior. There's also contributing factors such as icing, where a gas vehicle takes up the parking spot you need to use your charging port, and charging deserts where there's just no stations available. I put the link in the slide so you can look up and read the article if you're interested. Challenges that designers have when locating a charging plaza is there adequate power capacity to provide what's necessary for the number of vehicles? What's the cost of the power and the cost of the construction? Can the station be located close to where existing power infrastructure is? And are there amenities nearby for people can do something while they're waiting for their vehicle to charge? And there are special functions that are being evaluated, such as putting in a microgrid adjacent to or including the charging plaza, which may benefit some of the issues I just mentioned. Here's my one picture slide that shows kind of what we're talking about, multiple vehicle charging plazas. And I like to use the analogy that a fast charging Tesla uses enough load for 4 homes in my neighborhood. So it's a big 6.5 kilowatt load for the time it's charging, and that can present problems in some rural or not urban areas. I'm gonna go through these 2 one-line diagrams that'll give you an idea of the architectures that are typical. And this one is a local DC bus charging plaza. And I highlighted on the right that one thing that's common in these is there may be auxiliary loads in addition to the vehicles. There's, in many cases, a battery energy storage system, which is a DC source. And photovoltaic is often combined with that. That provides power to the DC bus, in addition to the AC generation from the utility. The EVs are charged off that DC bus. And I circled on the left the important distinction of this. Even though it's a DC bus, the point of interconnection with the utility is the point we need to be concerned about when commissioning these systems. This is another charging configuration, an AC bus. You still have these local loads and sources, but the control of the system by the fast charging system as managing an AC bus. And again, there's a point of interconnection. In both cases, that's the relevant point at which we need to be concerned for getting approval for interconnection.
Mark, if I may interrupt.
Please.
Interrupt for a second. Yeah, I think the important part is Mark circled that point of interconnection, okay? If you have a solar generator in there, and even if you have a battery storage system, you now have a generator. And therefore, the interconnection rules we're going to be talking about, the interconnection standards are applicable wherever adopted in the U.S., which is a good percentage of the U.S. right now. These standards have been adopted. So these standards have to be of concern. We'll talk more about that later, but I just wanted to point it out on the one-line diagram. That is a critical point.
Okay. Thanks, Wayne. So here's a listing of some of the next few slides. I'm going to list some of the standards that are relevant. But the NFPA 70, the National Electrical Code, has articles on power transfer systems, solar PV systems, energy storage systems, and they all require that the equipment be listed and type tested to a safety standard. Inverters, according to UL 1741, I'll talk a little bit more about that because that's going through some evolution. I'm just going to hit some of the highest. UL 2202 for unidirectional, that's when the equipment's used for just charging, and UL 2594 for AC bus systems. These safety standards are testing for electrical hazards, fire hazards, mechanical hazards, and just being evaluated for what normally would be foreseeable as potential problems. There's some evolving requirements related to interoperability or communication, and that the requirements Wayne's going to go through in a minute, all distributed energy resources must have the capability to communicate key information through a remote local interface, and that could include, in the case of a battery system, the state of charge or the actual state of charge or the ratings of the equipment on that circuit. So the utility can manage the flow and connection with that power source. The remote interfaces must use one of the three protocols, IEEE 2030.5, IEEE 1815, or DNP3, which is typically a utility standard, and SunSpec Modbus. So if those three, you don't have to have all three, but one of those has to be available. And I just mentioned some of the things we monitor. The principal standards that IEEE produces related to EV charging are the 1547 2018 standard, and that's actually undergoing a revision. But that is the current standard in force at many of those states that I mentioned earlier. 1547.1 is the test procedures for conformance to that standard, and it correlates very closely with UL 1741 for the inverter requirements. And then 1547.9, which was published a couple of years ago, gets more detail on interconnection with energy storage systems. And the unique thing about that, instead of just being a power source or load, it can be both. There can be bidirectional power flow. You can charge the batteries, or you can use the battery to export power. And then lastly, the one that UL 1741, the inverter standard, is being developed, a supplement SC. I'll talk about that in the next slide, I think. There's some other IEEE standards for your fun reference. 2030.13 talks about the interoperability of fast charging stations, and 2030.11 talks about DERMS, or distributed energy resource management systems, where energy sources are aggregated. That's becoming more common. The UL standards, which are the type testing standards and safety standards, 2202 for DC charging, electric vehicle supply equipment for AC charging, and a list. Not going to go through the list, but you have that for your reference. 1547.9 I just mentioned, but it is important in that it talks about energy storage specific terminology like operational state of charge. How much capacity is really available in that battery at its current state? How do we handle black start? And one of the issues that comes up with storage is fast frequency response. And safety, of course, related to batteries. Here's one of the new developments that's going to be important for vehicle charging is a standard that's under development for bidirectional power flow. And the title is UL 1741 Supplement SC. There's a typo on there. It should be SC. It introduces the concept of interconnection systems equipment. And the picture on the bottom kind of shows what we're talking about, that the vehicle will communicate via SAE-J3072 to a battery vehicle supply equipment device or system. And that system will communicate to the utility for the interconnection requirements. A background on that is the vehicle manufacturers typically will not agree to a field type test for an interconnection. They want to have things that are approved in the factory and then it's out and it's good. And the utilities in general would like to type test everything. So this is a solution that we think the industry is going to evolve to, where there's an interface that meets the electric power industry needs as well as the automotive industry. And we're working forward to publishing that probably next year. Yeah. Okay. I think I'm going to hand it over to Wayne now for the rest of the presentation.
Okay, you just put that down. Thank you.
Awesome.
Okay, thank you, Mark. So let's just talk about what we're focusing on and related to. So what I'm going to talk about on most of our discussion the rest of this morning, or with the remaining hour, is about IEEE 1547 standard, okay? And that is the standard for interconnection of DER to the grid, okay? That standard has been adopted, like Mark said, by many utilities. There's various levels of adoptions. There's states have adopted it, utilities have adopted it, and regions of operation called ISOs, typically are regional operators, they've adopted it. So it's widespread throughout the United States where the adoption is. IEEE 1547 is also in reference by FERC also, so there's a level of adoption. So as we talked about in the one-line diagrams, and as Mark identified, this is all relevant for us, okay? Anytime you have any kind of generation, and we're going to talk about V2G, but it includes anytime you have operation as a backup generator, for instance, as long as it's not like a UPS system or automatic transfer scheme. If it's paralleled with the system for more than a few cycles, there's an exact time frame, this is relevant, even emergency backups. So keep that in mind as you talk about as we talk about this stuff. So all I wanted to show here is the scope that we talk about is about that interface right there in that top left of the diagram. And that's what we're going to be talking about. I'm going to go through really quickly a lot of slides. If there's something that's not clear, they said save question and answers to the end. No. Raise your hand, we'll get a microphone to you, and because we want to clear up anything up front. Okay, with that, so the middle bottom right of this diagram really just shows, when we talk about communications, as you know, if you do any communications related areas, there's a lot to it. And we're only really focused on that little X area right there in the middle. that little X area has what we are concerned about in interoperability. I'm not going to talk too much more on interoperability because I want to really get to the commissioning stuff, that there is relevant interoperability and protocols that Mark talked about a minute ago. Then I want to go right into commissioning and testing requirements and recurring testing. Okay, the standard has commissioning requirements. There's, I don't know, 40 pages of commissioning requirements that have to be done. The follow-up standard is 1547.1 that has the methodology to do your commissioning, or a recommended methodology, but there's options there. But there are definite requirements, probably about 40 pages of tables of exact requirements that need to be accomplished. We're not covering those 40 pages today, but we'll give you a good outline. I did want to talk about, there's different levels of requirements, and you can look at it from the standpoint is there's an interconnection screening. I'm not going to take a lot of time on this. Like Mark says, you have the slides available to you. So just take a look at this as sort of, there is a in-depth screening all the way down at the bottom whenever things are very complex, and there's some preliminary screenings to determine, what is the level of analysis and commissioning that is required. So with that, I'm going to go to the diagram I'm going to spend a lot of time on here. Okay, we got to do a little different versions of this. Okay, and these are the high-level test and verification requirements. Okay, so let's talk about, the diagram starts at the bottom. Okay. And these are all requirements in 1547 for any of the interconnecting devices. So that includes inverters, but also includes generators, okay, rotating generators, whether induction generators or synchronous machines. And yes, it goes hand in hand with the old 1741 certification. And yes, there is rotating generators that are certified, not just inverters. So it applies to all of them. But the first test is a type test. And there is specific type tests that need to be accomplished. And the manufacturer, in order to confirm certification to 1547, or compliance with 1547, has to go through the type test. Okay, and of course, type test is done on a sample of various sizes and types, and we'll talk a little bit more about that as time allows. Then is production tests. We leave the production test mostly to the manufacturers on what they see as the essential production test, but there must be recorded production tests. We don't, every single unit, whether it's a 1 kVA household unit, or a 5 megawatt generator, has production test requirements. Okay, and I did want to back up. The 1547 requirements apply to any size, as long as it's connected to the distribution system. So your household system with solar system or wind system, or if this entire part of the city is interconnected, these requirements apply. Yeah, a question, please? Wait 1 minute for the microphone because I can't hear you.
Thank you. Thanks. Thank you. Can you hear me now?
Yeah.
So does it apply to combined heat and power equipment as well? Generators that generate heat and power?
Electric generators, well, I'm referring to, yes. If it's a CHP, it's
CHP,
yeah,
CHP.
What you're talking about, yeah, those generators are required to meet these requirements.
Okay.
Yeah.
Thank you. Thanks so much.
Thank you for the question. Okay, so we talked about production test. Next is our design evaluation requirement, okay? So design evaluation is a desk study, okay? So we expect the commissioning organization to be in touch very early in the design stages and phases of this thing, because you want to understand and make sure you understand what the design of the equipment is, what the equipment specs are, how it's put together, how it meets the interconnection requirements. So like I said, I have 40 pages of tables of interconnection requirements. We got to get an early start to make sure everything meets the requirements. Well, as you all know, whatever comes in the desk study, whatever specs come in, whatever you see is never what you see in the field. okay? So that's why we have an as-built installation evaluation, okay? And that is performed on site. These are basic checks, okay? These are basic evaluations. Doesn't require testing. It requires inspection, verification, a lot of documentation verification to make sure what is in the field matches the design evaluation. So, you know, to take a quick example, if you find out that you have a different inverter, for instance, or a different protective relay system maybe, okay? And it doesn't match up, it's got to go back to the design evaluation stage, and whoever does the design evaluation, which would be a third party, could be commissioning agent, could be another third party, sometimes it's a utility, has to re-look at things with the exact items found in the field. So you do the as-built installation evaluation. From the design evaluation and as-built installation evaluation, there are commissioning tests, okay? Now, in this requirement, for the most part, the commissioning tests are simple because it was expected that the overall commissioning of all the equipment and so on, which is what most of you folks do, I believe, you know, has been done, and then you get to our recommendations on the commissioning tests, okay? And so every system has some level of commissioning tests. Very simple systems, little household solar systems, do have some commissioning test requirements, okay? They need to be accomplished. Likewise, if there's big changes from the design evaluation, or if the type testing does not meet, we'll say certification by UL as an example, then there might be some very complex commissioning tests, okay? Some of which, for large systems, may be impractical, okay? So we step back and say, if you want to be approved and show compliance for 1547, you need to do the proper type test and so on and so forth all the way down the line, and not wait till the end, because one of the side points is frequency ride-through. How do you do frequency ride-through on a 10 megawatt generator? It's doable, and we have friends that would be glad to rent the equipment to do it. Nobody can afford it. Okay, and then of course periodic testing is another requirement. That is more of a general requirement. We don't put a lot of parameters on there. Our focus really is on, you know, the middle of this grouping, but these are firm requirements to get you. I shouldn't say you'll, but to confirm compliance with 1547. And I think I've talked through most of this slide, and I think I've talked through most of this slide. So I'm just going to go on to just a quick look. I'm not going to spend a lot of time. We could spend half hour on this slide alone, and we don't have the time to do that. But the point being here, that there is, if you remember, Mark had the point of interconnection, the POI on that left of that one-line diagram. And that is what we call in the terminology of 1547 PCC. So just think of the point of interconnection. It could be where the utility connects up to the facility. If it's a simple house, it's often the meter. Where the meter is located is that point of interconnection. Might be a disconnect switch, could be a variety of things, okay? So when you see PCC, that's what we're talking about, okay? So we actually have four different types of systems that we are looking at. We are looking at what we call a DER system, which is a system that has been fully type tested all the way up to that point of interconnection, okay? So if I think of a simple home system, I have a solar on my roof, interconnected to an inverter, and that's interconnected through the wiring of the house to the utility, okay? And that's typically at your meter or at your main breaker, depending on the utility circumstances. That would be the point of common the PCC, the point of interconnection. So if that is type tested all the way to where the terminals hook up to the wires in your house, that's a DER system, and that's type tested. And in the United States, could be UL certified. There's other certifying facilities, but that's the methodology. However, many manufacturers say, and especially as you get to more complex systems like commercial buildings and campuses and hospitals, it's pretty hard to type test all the way up to that high part of the transformer, okay? So if you got a 480 volt system, for instance, or as a for instance, you might be connected at 13 kV to the utility, as a for instance. And so in those cases, to be a PCC DER system, you have to be connected to the utility directly, okay? So this would be a composite where the transformer and maybe some protection systems were not able to be type tested, especially as we get to larger systems, and that gets us to a more sophisticated analysis and more detailed evaluations and more sophisticated commissioning process. So.
Wait, are you saying that it's on the utility side of the meter?
Yeah, no, on our side of the meter, on the commercial side of the meter. Thank you for the question. Yeah, the question was, which side of the meter was I referring to, and I meant to this side. Everything I'm talking about is we're responsible for everything this side of the point of interconnection. So, and so that's what we need to be concerned about. POC is really simple for simple systems that you just have a device sitting out there. It's fully type tested. Same kind of concept. I won't spend any time there. And again, a lot of detail here that we could take the next 4 hours to talk about. Anybody wants to come out in the hallway, I'll be glad to talk to them 4 hours till I catch my flight. But I hate to see guys glazed over also. Okay. I think I talked through most of these slides, so we'll go through this a little more quickly. Type testing. Any questions on any of this, let me know. Production testing. It's, again, a test on every unit. Okay, let's spend just a second more on DR evaluation, which is the design evaluation, and that's your interconnection review process. And then DER as-built evaluation, again, the in-field checking that everything is as it says it is. And, even for simple installations, and you guys deal with very complex installations, I understand, but even this little part, this interconnection, for even simple installations, it gets quite sophisticated, the amount of paperwork of documentation that is done. At least not is when they say something is type tested. Has it been type tested? You have to check back with the type testing at NERDL on making sure that it shows up. There is people that don't quite follow that rule. Okay. Again, design evaluation to dust study. Okay. I want to be clear, in what we say and what we have as a requirement, we don't say who does what. Okay, that is more of the contract between the utility and the owner, okay, on who's responsible for what. So for the DER design evaluation, I think in general it's being done by the utility, sometimes in cooperation with a third party, okay, and sometimes a standalone third party. Obviously, the owner has to work very much in cooperation with them. As commissioning, this is a piece of information that we need to make sure we understand. And in practical application, as you all know, when you get into the real field, you're going to be talking to these parties because they've done an incomplete job more than likely. Okay, so serious questions need to be done. Again, in your contracts, it might be very well you guys would do this part also as part of it. It depends on how you want to form your contracts and what the utility and the owner is comfortable with. The who does it is not any part of the standard. There's just a lot of methodologies that are being used right now. Okay, the as-built installation evaluation. Again, is just to make sure all the paperwork lines up as the equipment as installed. Frankly, when I'm doing an installation, I've done several large installations, acres of solar cells, okay, with many inverters and that kind of thing. I get to walk. I get some good walking time, okay? Tops of buildings, solar on tops of buildings, very, a lot of good inspection time, and there's a wide variety of things that are, that need to be looked at. So, okay, now I'm going to go to commissioning tests and verifications, okay? Okay. There's different levels of commissioning tests that are being done, okay? And so we're sort of looking at the requirements, not saying who it is. Each manufactured device has typically, when I talk about inverters in particular, but also breakers, transformers, typically the vendor will make sure their equipment is operating properly, okay? So they have their list of commissioning requirements, okay? That list may or may not line up with what we're talking about here on this requirement. So for instance, if you're talking about a transformer or a piece of switchgear, they're used to doing switchgear testing. They're not used to doing interconnection testing for these requirements. So we have to make sure that these all line up. So from a commissioning tests, from the 1547 requirements is, you want to make sure all the devices and all the combined devices are able to be tested as the system that they are. And so it takes a good look at understanding the systems, and that's your expertise in this room. It's, how does the system work? How is it supposed to work, okay? And do we meet the requirements on these systems, okay? So it includes visual inspections. There's some simple operational tests, like I said, even at the home level, okay? That need to be done just to confirm, okay? But if you don't meet the requirements, there is, I'm going to guess the number, it's 40 some line items of sophisticated tests that need to be done. Each of those tests are, 1 to 5 pages of written material. So, it could get quite sophisticated depending on what the need is. Ideally, the customer will have done most of the testing and the type testing that needs to be done in the design evaluation. The importance of the design evaluation is in some cases we are allowing simulations to take place of some of the in-house tests, okay, for obvious things. That's an agreement between the utility and the owner that needs to be confirmed that is allowable. Okay, I'm not going to spend any time on this. We just sort of identify basic and detailed tests. And then periodic tests, I'm not going to talk about today, but there is periodic tests and verifications. Okay. And so how does this apply to everything that you're doing day to day, whether it's V2G or not, is if you have a generator that is hooked up, that is ever paralleled, okay, in many, if not most jurisdictions in the US and many worldwide, IEEE standard 1547 is applicable. So these requirements are essential that they are confirmed. If they are not confirmed, they may not, depending on the contract and all, be in compliance with the utility interconnection agreement. So all part of the things. And yes, it applies to any kind of facility you're working with, whether it is a house, a subdivision, a commercial building campus, a hospital, a industrial plant, everything, okay? And standalone power systems. So it applies to all of them. Anything hooked up to the distribution grid. Okay, so that is what is in 1547 from a general compliance standpoint, and what needs to be required. As I told Mark this morning, and he knows me for a long time, so he knows this, I could talk on the slides that you and I just looked at for, I don't know, what we take, 10 minutes, 15 minutes here, 20 minutes, or for 8 hours. So, there's a lot to it, but I just want to give you an overall. Now, IEEE has started a new program that may be very applicable to you. It's called conformity assessment, okay? So we just talked about all the requirements in 1547. The methodology is in 1547.1. I am chair of a group called IEEE 1547.2, which is the guide for 1547. If you are, any of this stuff is important, probably get all three of those, okay? I will say the guide was a little bit longer than I wanted in production, but it is over 300 pages of, and I've heard this in several presentations, of sort of the best practices, the how-to, really cutting-edge stuff. So those, if any of this is relevant to your day-to-day work, you know, these are important documentations to understand how it all works together. So now I'm going to talk about the conformity assessment program IEEE is doing, okay, and what it's about and how it applies to people in the room. Okay, it is a certification process that is focused on credentialing individuals, okay? Trains and certifies individuals who verify that any installed DER interconnections for its compliance with IEEE 1547, 2018, okay? So it is, we'll talk a little bit more about it in a few minutes of how it is entailed and how it works. But what the conformity assessment is, and I'll just go right into the next slide, is an industry-accepted method of demonstrating a product adheres and conforms to a standard. Conformity assessment can include testing, inspection, certificate issuance, and registration through extensive program support. The program facilitates and administers certification programs designed to evaluate and confirm product features and functionality. Okay, so we're going to talk about the one for 1547 for DER, for interconnecting generators to the utilities. There are, I think, 8 other programs of conformity assessment, ranging from nuclear to AI to I'm going to run a mind blank on the rest, so we'll just move on. So, but there's several programs, different variances in the electric industry, and so we'll talk about this one. And so, the whole idea of the conformity assessment program is to confirm compliance to 1547, 2018. I just told you there's 40 pages of tables, and I forgot what the document has, 150 pages, I'll guess, okay, of document on 1547 to understand. So commissioning people that are, you know, owners, operators, installers, you know, try to follow these requirements, but we want to focus a little bit more on, have we met the requirements? So it's that last check, if you will, and I'll show you that in a minute. And I'm just going to, go right up to here. And this is sort of the way, I know you guys are more sophisticated than the simple roadmap, but you know, basically, this is a simplistic way of thinking about it. And I'm going to really start, you know, you got the contractual agreements, you got the interconnection agreement, okay? You got type testing equipment going on. You know, and then there's factory acceptance testing and production testing going on. Eventually, the equipment is delivered to the site, and the site construction continues. And at some point, you are allowed to energize the equipment somewhere in the midst of the commissioning. Those boxes should all be intertwined a little bit, as we all know. But there's, you know, there is the commissioning test requirements that need to be done. And then the question is, does it meet compliance? Well, that red box is where the conformity assessment program looks at. Is we have all the proper commissioning tests been done, and the net result of this is a report that identifies exactly what you found in a conformity assessment. Okay, so I just wanted to identify the conformity assessment program is a training and certification program for individuals. Okay, and we'll talk about that a little bit more in detail, okay? So I'm going to back up one slide now to just give the overview now that you sort of saw the one-line diagram of it. There is It covers any of the DER, which is, wind, solar, battery, electric vehicles. Yeah, let's back this up to electric vehicles because I sort of forgot we were talking about electric vehicles here, okay? When we saw those one-line diagrams, what we saw is that charging stations would have solar panels, maybe, would have battery storage, makes that all generators, okay? We're not there yet, but quicker than you would hope. EVs will also be bidirectional, okay? The vision is, think of you charging your EV at home, bringing it downtown, parking it in a parking garage that has a charging station, okay? And the utility needs your energy in the middle of the hot summer day. Helps us with its peaks a little bit. It pays you to buy electricity from your car and then recharges it before you go home in the evening. Just a vision. We'll see how it actually is implemented. We're a few years off from that. I mean, we are working on a standard right now. Actually, the revision of standard, it comes out 2026. We'll have some visions of that going forward. How it's implemented, it takes years for these things to get implemented, but you'll see that before you know it. So, so there's many ways where anytime you have charging stations, and of course I'm talking electric vehicles, and we think cars. Don't forget those big truck plazas. If the division of electric trucks, Mark said 4 houses for a car. How many buildings like this for a truck? Okay? Giant consumers of electricity. So just to move forward here, the certification program is a certification of individuals. I think that says completely there, so I'm just going to move on. And we have a specific methodology for doing this conformity assessment, and that is pre-site efforts, on-site efforts, and after on-site efforts, okay? And I could go through a lot of details on all that, but I think the important part is if we look at the whole process of how this is all put together is a facility is being built, whether it is a V2G facility for charging, and that's what our focus is this morning, help the sustainability effort and so on. How ideal. Solar panels feeding the EVs, excess solar gets sold back to the utility. It's a win-win-win-win. But who is doing what, okay? Well, there's the owner, operator of the facility. There's their architects, engineers, civil engineers, whoever's all involved in the whole thing. There is the interconnection agreement with the utility, for loads, that's one of the interconnection agreement. Once you're generating, much more sophisticated interconnection agreement. Who is overlooking the whole thing? And that's where the level of commissioning requirements is identified of who needs to be looking at the whole thing in the interconnection standpoint. And then going through the whole requirement thing, we get into this conformity assessment program, which just basically is a confirmation by a third party, okay, that everything has been done completely, okay? And conformity assessment people could be people in this room, could be other people that are properly trained. The utility and the owner would agree that this would be a final assessment on just our narrow focus here on the interconnection and the interconnection to the utility. So with that, I do have a question in the back of the room. If you could wait for the microphone. I don't know if he has that mic on. What slide would you like? This one? Yep. Yep. The utility approval, I can't hear all the words. The gentleman could turn up his microphone. Thank you. Yeah.
He was asking
Yeah, okay, sorry. Yeah, the question was, does the utility have final approval? Okay. And for the interconnection agreement, yes. Okay. The conformity assessment program would provide input on whether you met the requirements, okay? So a report would identify whether requirements have been met, okay, and its assessment, and where requirements haven't been met, what requirements haven't been met. In a practical purposes, we always know there's punch lists and stuff, okay? So in practical purposes, we would expect everything to be met in the final report to say everything has been met. In some instances, the utility will allow exceptions, but that would be the final, for the interconnection. Now, we still have the normal owner-operator type thing, but we're really narrowly focused on making sure that the utility is focused. Does that answer your question, or go ahead with a follow-up? Yeah. Yeah, it would be an interactive process for sure. Yeah. Yeah. Yes. Yeah, the question was, I should have repeated it, is would the commissioning agent come back? Would the contractor come back? Yes, it would be an interactive process. So I just want to say one more thing here, and then if there's any other further questions. So the conformity assessment program is a program, and we have many people trained. Use in the different parts of the country is just on a startup stage right now for this program for the 1547 related stuff. But if anybody in the room is interested, we have 2 schools coming up. They're going to be virtual, so you don't have to travel. One will be in August and one will be in October, so let us know if I don't know if we have a slide with our contact, but see me afterwards and I'll be glad to give you contact information. So with that, I think I'm at the conclusion of my remarks. And Mark, do you have any comments before we get to questions?
I'd like to wrap it just by, hopefully you saw the theme that these standards are evolving, and we'd really like to get commissioning agents and people involved in commissioning involved in the process. So through our contacts, we can get you involved in the working groups. A little story about my history. I worked at Kohler Power Systems back in the late 90s and 2000s trying to do critical systems, emergency generators, and it was a very undesirable business because each utility requirement was different, so all the equipment was custom, all the controls were custom, and it was like pouring money down a hole to try to sell generators. But as soon as the 1547 first standard in 2003 was approved, it took about 2 years, and the business revenue multiplied by 5-fold. We saw the data center boom starting to happen, and a part of that was the fact that the rules were now known to parallel to the electric grid. That went on for 10 plus years, and now the utilities were worried about circuits that had a high penetration of inverters, renewables, and that was causing some problems in the electric grid, including some entire system events related to the inverters behaving the old way. So we added rules like ride-through and voltage regulation so the inverters can help the grid if there's an undesirable condition. Now our evolution's dealing with things like vehicle-to-grid, more energy storage, microgrids, and so we'd love to get your input in many ways. We have standards committees, and we have industry connections groups that just bring a variety of people together to provide input on where we need to go, where our gaps are. So that, our conclusions are, hopefully you got a sense that electric vehicle supply equipment needs to be commissioned according to these standards we just reviewed. There is need for reliability improvement, and the existing testing and commissioning requirements apply. And I hope you found this helpful. The information is on the slides, and you can feel free to reach out to us if you'd like more information, such as where this information is mandatory, what parts of the country.
We do have a couple minutes for questions. Is there any further questions today? Go ahead. Wait for the microphone, please.
Work all over the country and work with some of the big box retail people that they've put in, say, 500 kW standby generators. And in some areas, the local utility absolutely refuses to allow parallel generation.
Yep.
So I guess my question is, do you see that across the country? And maybe just rule of thumb, what percentage of people just say you can't do that?
You know, I really haven't heard of that much, okay, so I'll say it that way. But, you know, the utility industry is interesting because in the U.S., I think we have like 500 entities that are called themselves utilities, and they all make their own rules.
Yes.
Okay, so that is the issue that we all are up against. So it doesn't surprise me what you said. I haven't run against it myself, but yeah, I could see that happening. And yeah, it's just local issues. Yep.
Yeah, it's in our case, the most difficult to deal with is in Southern Virginia, and it's a fairly large, utility group. And the rest of the country, the southeast anyway, we don't see that issue.
Yeah, it's really very localized and somewhat regional, but usually very localized, and that's what we find on even the requirements that we have here. There's adoptions and adoptions with exceptions, and that's all very, very local concerns. Did I have another question here? We have.
Thank you, Wayne and Mark. It was really a good presentation, and I appreciate IEEE's participation and willingness to share the information and bring it out, because there's a lot of people who could make a living doing this.
Yep.
So I appreciate that. I got a question for each of you. Wayne, on your diagram that was the block flow chart, and
Yeah.
you had the as-built process, and then you had the commissioning process right above that. I'm kind of curious how you do with observations, checking for loose wiring connections. Is that where you would apply like NETA torquing standards, and then would you do more NETA testing in the commissioning part?
Okay, so in the commissioning part, I would expect most of that to have been done, and then during the visual inspection is where I would apply some of that, depending
You would
on.
sample like torquing.
Yeah, do sample. Depending on the circumstance, I would do samples, or I would do, a large percentage. Also, I would look at documentation that has proved that they've actually done it also. Okay. But I'm big on. I was raised in General Electric, and we're big on sampling things. That come off the production line. So I'm big on sampling.
You're a show me guy. So, Mark, you talked about the evolving standards of fast chargers. My understanding is that the new standard is the Tesla fast standard charging. Is that true?
It's very similar. All three of those are somewhat compatible. Thank you. I did want to highlight this link here. It's in our presentation. We have a map on that website of where utilities consider 1547 as mandatory, which states have adopted it as a regulatory process, and that might drive some of the behavior we're seeing with resistance. Okay, well, we'll hang around for a little bit.
Thank you much.
Thank you very much.